Welcome to a series of videos looking at trigonometry. I'm your presenter, Aaron Lewis. In this series of lessons, we'll be looking at right angle triangle trigonometry, using the sine rule, using the cosine rule, calculating the area of triangles and problem solving, and graphs of trigonometric functions. In this lesson, we are looking at graphs of trigonometric functions. In this lesson, you're going to learn about the graphs of trigonometric functions. This will include using your calculator. This lesson is suitable for students who will be taking A-level mathematics. The language of the lesson is English. And this lesson should be around 30 minutes. Today's learning aims are to be able to use features of the sine function when drawn graphically, to be able to use features of the cosine function when drawn graphically, and to be able to use features of the tangent function when drawn graphically. So here is the sine function. Pause the video and write down any features that you can see. Here are the notable features that I've got. The graph has a period of 360. You can see that it repeats itself every 360 degrees. It has a maximum value of 1, sometimes called the amplitude, and has a minimum value of -1. And you might notice that between 0 and 180, this 90-degree line here is a line of symmetry, as is this 270-degree line here, and with this line, and with this line here. So today, we're going to be using the features of this sine function to solve some trig equations. Here is the first problem. So we are given that one solution to the equation sine x equals 0.5 is 30 degrees. And we need to find all the other values that satisfy the equation between -360 and +360. First thing I've done is I've drawn the sine curve between those values. There is 360 degrees. This is -360 degrees. There is -180. There is 180. There is 270. There is 90. There is -90. And there's -270. You don't need to label all those, but getting a rough idea of the sketch will help. So the next one we're told is that sine x is equal to 0.5. And there is the 0.5 line. So I'm just going to, in red, circle those solutions. There's one there, there's one there, there's one there, and there is one there. So the first answer is x is equal to 30, which is here. And there you go, you can see it there. So what is this other value going to be? Well, we know that this gap here between 0 and 30 is 30. And that is going to be the same as this gap here, which is also 30. So therefore the second value is going to be 150 degrees. How do you get the other two values? Well, we know that the sine function repeats every 360. So this graph here, if I subtract 360, will give me this one. So I need to take my two values in red here and subtract 360. So 30 subtract 360 gives me this one, minus 330. The next one, 150, take away 360, gives me that one there, which is minus 210. And the last thing to do is just to write the answers out in order from smallest to largest. So 4 solutions. Here is your question. Pause the video and have a go now. Here is the solution. So this time sine x is equal to minus 0.1. The first solution from the calculator is 185, which is here, 0.74. Just going to zoom in. And so we can see that this gap here, if this is 180, this little small gap here is 5.74. So this gap here is going to be the same because it's symmetrical. So to get my second value, I've done 360 subtract 5.74 to give me 354.26, which is that one, and the other one was 185 there. How do I get the other two answers? Well, I get both of those and subtract 360 from both of them. And there we go. So my final answers, written in order from smallest to largest, are there. And all I'm doing is using the symmetry of the graph. Here's another question. This time I'm told that sine x is equal to 0.4, and it's where x is between 0 and 180. So the first thing I'm going to do is to draw the graph between 0 and 180 degrees. So the full curve would have looked something like that. And there's 360. But we don't need all of that. There is 90 degrees there. So sine x equals 0.4. So I'm going to draw a horizontal line at 0.4, and you can see my two solutions there. Now the first solution I'm going to get from the calculator. So the calculator, when I type in inverse sine 0.4, it gives me 23.58 degrees, which is this one here. So therefore we know the size of this gap here. Just zoom in a second. So the size of this gap is 23.58. So this gap here is also 23.58. So the second solution will be 180 subtract 23.58. So my second solution is 156.42. And there are the two solutions written in order. Here is your problem. Pause the video and have a go now. So here's the solution. First thing I've done is I've drawn it between 0 and 180. So there's 180. There is positive 180. There is 0. And where sine x is equal to 0, which is the horizontal line here. So first thing I've done is typed it in my calculator, which gives me 0. And then if I add 180, it gives me this one. Subtract 180, it gives me this one. Again, I'm only using the graphs to help me. The final set of problems using the sine function. This time we are told that sine squared x is equal to 0.25 between minus 180 and 180. So the first thing to know is that sine squared x is the same as sine x all squared. It's just a different way of writing it. So the first thing to do is to square root both sides, which leaves you with sine x is equal to the square root of 0.25. And because we're square rooting, we need to take both the positive and negative root. The square root of 0.25 is 0.5. So I'm looking for the values of x, values of sine x, which equals either plus 0.5 or minus 0.5. First thing I'm going to do is I'm going to work on the positive 0.5. So I've sketched the function between 0 and 180 degrees. I've drawn in a line where 0.5 would be, and I can see two solutions. One there and one there. Using my calculator to get the first value, inverse sine of 0.5, and the size of this gap is 30 degrees. So the size of this gap will also be 30 degrees. So my second value there is 150 degrees. This time, if sine x is equal to minus 0.5, I'm doing the same thing. I'm sketching, and there is minus 0.5. And you can see two solutions, there and there. The first solution I take from my calculator. I write inverse sine of minus 0.5, and that allows me to get that minus 30 there. So we know that the gap here is minus 30. Or 30. So the gap here is also going to be 30 degrees. So minus 180 plus 30 is a minus 150 degrees. So writing those four solutions out in order, I get x is minus 150 degrees, minus 30, 30, and 150. Here is your question. Pause the video and have a go now. Here is the solution. So the first step was to divide both sides by 2 to get to this line here inside of the bubble. To get to this line here. And then I've square rooted both sides. So your calculator will either give you 1 over root 2 or root 2 over 2. Doesn't matter, they are equivalent. On the left hand side here I've dealt with the positive square root, On the right hand side I've dealt with the negative square root. I've drawn the function between 0 and 360. I can see I've got two solutions. The first one has come from my calculator, so that's 45 degrees. This one here is going to be 180 subtract 45 degrees, which gives me both of those two solutions there. The next one, between 0 and 360, so this bit here is disregarded. My calculator gives me the minus 45, but that is not within the region. So if I add 360 on, it will give me this one here, which is 315. And again, I'm going to notice the gap here of 45 degrees. So the gap here is also going to be 45 degrees. So that's 180 there. Plus 45 is 225. Have a go at mini quiz 1. Pause the video and have a go now. This time we're going to look at the cosine function. Here is the cosine curve. It looks very similar to the sine curve, but not quite. Pause the video and write down some of the features that you can see. So here are some of the features that I found. The cosine function repeats itself at every 360 degrees. You look here to here, and here to here, you can see that is repeated. It has a maximum value of 1, just like the sine function, and a minimum value of -1. And looking carefully, 0 degrees is a line of symmetry, and so is 180 degrees, and we'll be using those today. So with our first problem, we are told that one solution to cos x is equal to 0.3 is 72.5 degrees. And then we need to find the other values which satisfy that between -360 and positive 360. Here we go. So first thing I've done is I've drawn the curve. I've drawn in a line of 0.3, and you can see that I'm looking for 4 solutions altogether. So the first solution is 72.3, which is there. So that is 0.5 degrees there. To get the other solution, which is here, this gap is also going to be, by symmetry, 72.5 degrees. And also this gap here, look, is also 72.5 degrees, which gives me this second solution here. The third solution, so this one here, sorry, that one's x1, this one's x2, this one's x3. And the final solution is going to be 360 it's going to be minus 360 add 72. So if I have a look over here, this gap here is also going to be 72.5. So this one here, look, is minus 287.5, or we know that it's symmetrical about there. So I could have found these two and then used the symmetry. So in some ways the cosine curve is easier to use than the sine curve. Writing those answers out in order. There you go. There is your question. Pause the video and have a go now. Here is the solution. The first solution came from the calculator at 95.7. So I can use some symmetry to get the second solution. This solution over here, we know the size of this gap is 95.7. which gives us 264.3. And again, I can use symmetry to get minus 264.3 for that one. Some more complicated questions this time. So the first thing I'm going to do is I'm going to sketch cosine between 0 and 180 degrees. I'm going to draw in a line of minus root 3 over 2, which is around 0.866, but it doesn't need to be exact. So what I'm going to do is pick up my calculator. X comes out as 30 degrees. There is only one solution in this case, and that's the question finished. There is your question. Pause the video and have a go now. And here we go. So I've drawn the cosine curve between minus 180 and 180 degrees. My calculator has got me the first solution, and then I've used symmetry to get the second solution. Final question. This time I've got 2 cos squared x equals 1. So the first thing I'm going to do is divide both sides by 2, which is going to give me cos squared x is equal to a half. And we know that means cos x all squared is equal to a half, because these two are equivalent. Then I square root both sides. Therefore cos x is equal to plus or minus the square root of a half. I'm going to deal with the positive square root on the left and the negative square root on the right. So I've sketched the curve between minus 180 and 180. Just going to put where those endpoints are. The first answer I'm going to take from my calculator, inverse cos of the square root of 0.5. So my calculator gives me the first value of 45 degrees. I can find the other one by using the symmetry. So the second solution is minus 45, and that's working on the positive square root. And on the right hand side here, looking at the negative square root, again I've drawn it. There is approximately the square root of minus a half. My calculator will pick up the first value, inverse cos of the square root of minus the square root of a half, which gives me 135 degrees. And using symmetry will give me the other value. And the answers written in order are there below. Here is your question. Pause the video and have a go now. First thing to do is divide both sides by 2. So cos squared x is equal to 1. Square root both sides, we get plus or minus 1. We're sketching the curve between 0 and 360. We pick up the first value from the calculator, so that's inverse cos of 1 to get 0. And you can see from the graph that the other one is going to be 360. The other value, cos x is equal to minus 1, which is down here. Your calculator will pick that one up straight away. And there are the 3 answers in order. Pause the video and have a go at mini quiz 2 and press play when you're ready. And our final function to look at is the tangent function. It is unlike the other two. And there it is, between 0 and 360. Pause the video and write down any features that you can see. The first feature to see it has a period of 180 degrees. It repeats itself every 180 degrees. It has no maximum value. It has no minimum value. And it has asymptotes at 90 and 270. Now, an asymptote means that the graph will get closer and closer to that line, but never actually reach it. And if you type in your calculator tan 90, it will give you math error. Now, tan is really nice because it repeats 180 degrees. The solutions are really easy to find. So here we go. So we're given one solution as before, and we're given a range of degrees to find it between. So the first thing I've done is I've drawn it in my calculator. On my page. Between 0 and 360, there's quite a lot to draw. So you've got asymptote here at 90 degrees, 270 degrees, minus 90 degrees, minus 270 degrees. So the first answer is 45 degrees, which is here. Now, tan is really, really easy to use. All you do is get your solutions and add and subtract 180 degrees. So the first value there is 45 degrees. The second value is 225 degrees. And then working backwards, we've got minus 135 degrees. And the last one, subtract another 180 degrees, is minus 315 degrees. So the solutions written out in order are those there. There is your question. Pause the video and have a go now. Here are the solutions. So you can see the first one is minus 71 degrees, which is there. If you add on 180, you get the 108.4 there. Add on another 180 will give you that value there. Subtract 180 degrees from the original, gives you that answer there. This time, we've got tan x is equal to 1.2, and we're working between 0 and 180. So I've drawn tan between those two values. 1.2 is about there, so I'm looking for just one solution, and my calculator will pick that one up straight away, and there are no more solutions. There is your question. Pause the video and have a go now. There are the solutions. So a quick sketch between minus 180 and 180. Make sure you're aware of where the asymptotes are. The first one is from the calculator, and if I add 180, it gives me the second one there. And there are my two solutions. This time, we're told that 2 tan squared x is equal to 1 between minus 180 and 180. So the first thing I'm doing is I'm dividing both sides by 2. Therefore, tan squared x is equal to a half. And then I'm going to square root both sides. I'm going to deal with the positive square root on the left. So I'm looking for where tan x is equal to the square root of a half, which is about there. You can see I've got two solutions. The first solution I can pick up from my calculator. And to get the second solution, I just need to subtract 180 degrees. And there we go. On the right hand side, I'm dealing with the negative square root. And There is the line drawn. Again, I'm looking for two solutions. The first solution is from the calculator, and then I'm adding 180 degrees to get the second solution there. And there are the 4 solutions written out. There is your question. Pause the video and have a go now. So the first thing to do on this solution was to divide both sides by 3 and then square root. So we're looking for where tan x was either plus or minus root 3. First thing to do is sketch. So my calculator will pick up the first value there at 60. Add 180, gives you the 240. The calculator will give you minus 60 for the first value, which is invalid. However, if we add on 180, 120 is then in range. Add on another 180, gives us 300, and it's now in range. Remember, we're looking between 0 and 360 there. And there are the solutions written in order. Have a go at mini quiz 3 and then come back to the video. So the learning aims of this lesson. The first one was to be able to use the features of the sine function when drawn graphically. The second aim was to be able to use features of the cosine function when drawn graphically. And the third learning aim was to use the features of the tangent function when drawn graphically. That is the end of the lesson, and thank you very much for watching.